Today, we're going to be looking at how do we continue using function notation to evaluate functions. So what we're going to be looking at for this is going to be page 5 of our notes. And so to take care of that, what we're going to try to do is to look at what it's going to be looking like to evaluate this sort of function using a graph. And what we had for our first day is we were going to be sharing a lot of things, and we're going to be looking at what it looks like to put an input value into a function, use the equation, plug the things in, and see what we get out for our outputs. What we have here with the graph is a set of all of the points and values that we're going to have along the way for the entire function. So we don't have an equation to represent it. We've got a graph, which is a set of input and output values put in one place. And then they're all going to be paired up as x and y values. So if we look at something like this, what I want to make sure that you're recognizing is we have a graph that's full of x and y values. And when we're looking to evaluate things like f of -1, f of 1, and f of 5, we're going to find those input and output values present on this graph. So what I'm going to do, I'm going to choose 3 different colors here to kind of have us figure out where we're going to be looking at this. Because what we have to recognize is that inside each of these is the input value we're going to be starting with. So if we're looking for f of -1, what that tells us automatically is that our input value, or our x value, is equal to -1 for that. And if I'm looking at the second one, where we've got f of 1, that means that our input value there is that x is equal to 1. Or for this last one, if I'm going to be dealing with f of 5, that means that my input value is going to be at a place where x is equal to 5. So what I want to do at this point then is to find out what are the y values on that graph that correspond. What are the output values that go along with that? So we'll do these one at a time. If x is equal to -1, what I'm going to go do is look here on the axis. And as I find on the x-axis, x equals -1 sits right there. Now, we actually happen to be very fortunate that the graph crosses the axis at this point, which means that the y value at that point is on the axis, which means that the y value is 0. That is going to be what the output value is at x is equal to -1. So f of -1 is equal to 0. Okay, so that gives us our first one, what we're going to be looking at. Let's see what happens when we're looking at x is equal to 1. So I go over here, x equals 1 is right there. Now, we don't have a graph that's crossing our axis at this point. So what we have to do is go up and find that point on the actual graph. So here, that's the place where x is equal to 1. The output value is the y value that we have right there that goes along with this point. So our y value at this point is going to be that y is equal to 4. It gives us an idea in terms of our output value for f of 1. And then for our last one here, we're going to be looking at what happens if x is equal to 5. So if our input value is 5, that's here. We go down to the graph right there and say if that is our point for where x is equal to 5, let's go all the way over the side and see. Well, that is going to be at y is equal to -3. So the output values in these cases are going to be our y values. F of -1 is 0, f of 1 is 4, and f of 5 is -3. That's how we look at the graph to be able to figure those out. Now, what they're asking us here for our second one is the same general idea. It's saying, well, we want you to evaluate f of 0. All right, f of 0, that's x equals 0. That's right here. That means I go up to the graph there. Our y value is 3. So f of 0 is equal to 3. I'll write that over here. And then ask what special feature on the graph does that correspond to. Anytime you're going to be taking an f of 0, where the x is 0, that is going to be a point that is on the y-axis. And so if there's a point that's on the y-axis, the name that we call that, that is called our y-intercept. So our y-intercept is at the point 0, 3, or what we've just said there is that f of 0 is equal to 3. That gives us an idea as to how these things relate to each other based upon the graph itself. Now, what I like about the way that this next part is going to be going through is it's going to be working backwards. So in the case of something like this, it asks you specifically what values of x or what input values solve this equation for f of x equals 0. So I'm saying if the output is 0, what are the x values that give you that? So here's what we want to do. Right now, if the output is 0, that is telling us we know that our y value is equal to 0. So I want to go back up to the graph and let's take a look at that and see what we can find. Now, y equals 0 is going to be anything on this line right here, because those are all values where y is equal to 0. So that means that I could find one right here. I could find another point right here. And I could find another point right here. These are all values along this line where the output is 0. Now, we already talked about using the vertical line test to figure out if we're going to be having a function, and clearly this passes the vertical line test. It's okay to have the same output value more than once. This just gives us an idea as to what we're going to be looking at. So let's figure out what our points are going to be. And each of these is going to be in terms of x equals. Now, I'm going to go here and then work my way down. So here, x is equal to -1 for that. And so in this case, x equals -1 is one of my possibilities. Then I'll put over here that is -1 comma 0. And I'll go back to the graph. Let's see, our next one is here. That's where x is equal to 1, 2, 3. So if x is equal to 3, that means I've got the point 3, 0. And then for this other one here, we've got 1, 2, 3, 4, 5, 6, 7. So x equals 7 gives us the point 7, 0. And then it asks, what special feature does this call? All of these happen to lie on the x-axis. And so anytime that we have a 0 for my y value, this is called our x-intercept. Finally, they're asking this question. We're not going to do a whole lot with something like this, but what this one is telling us is if I give you a specific output, and in this case, we're giving you the specific output of y is equal to 3, between what two consecutive integers does the largest solution to that lie? So that means there's probably more than one answer. We're looking for the biggest one. And since it's between what two integers, that means it's probably going to be somewhere in the middle. It's going to be a decimal. And so we want to see what we can figure out where that's going to be at. So let's go up and find our y equals 3. And in this case, 1, 2, 3, that's here. I'm going to draw this horizontal line so we can see it. The last time we had the axis, so that was much easier. We have 1, 2, 3 points here where the values have an output of something like that. Now, these two are whole numbers. This one's at 0. This one is at 2. This one is the largest, and clearly it falls between two numbers. So if I go down to the x-axis, this x is 7. This x is 8. So that is a point that falls between 7 and 8 for my input values. So x is between 7 and 8. And that's kind of the way that you use the graph to be able to evaluate the functions. That should be able to give you a general idea as to what it is that we're going to be doing for that. So with that being said, I will say, good for you guys and have a wonderful day.